Hello, this is Dan Watson. I'm here today with another version of the lube page. Now, as I tell you in each one of these when we start, give you a little bit of my own uh, credentials so that you know that I'm not just some typical guy on the internet, that it must be true he said it on the internet, even though he doesn't know what he's talking about. Okay. So I am a certified lubrication specialist. I'm certified by the Society of Tribologists and Lubrication Engineers. I've been in this business for 34 years, and prior to that, I spent over 20 years in the United States Navy in the nuclear propulsion program. So I bring some credibility to what I tell you in these, and in most cases, I will just be honest, I'm not going to tell you something if I'm not sure about it, because, hey, I'd rather not tell you than blow smoke. Okay, so what are we going to talk about today? We've been working through several different videos, about a half a dozen of them up to this point, where I've tried to lay in some groundwork of fundamentals so that when we begin to talk about what our subject is today, which is the formulation of finished products, that I wouldn't have to explain all the basics in order for you to understand what I'm talking about. So if you haven't seen those videos and you're logging in for the first time, I would advise that you take some time and look at those. They only run about 15 minutes apiece. One is longer because it's about viscosity and it's very important, and there's a lot of material there. But in general, you can bring yourself up to speed with where we are in about an hour and a half of time watching a few videos. So I built the groundwork so that we could talk about actually formulating or making a finished product. Now, what do I call a finished product? That'd be the motor oil that you buy on the shelf to pour into your car. That's a finished product, okay? Now, when we set out to formulate or make a finished product, one of the things that we have to understand and look at is, what is our objective? What exactly are we trying to make? Excuse me? My nose itches. Anyway, to be looking at, are we going to make a standard motor oil for everyday passenger car? Are we making a racing oil? Are we making a diesel oil? Making a small engine oil? Are we making a marine engine oil? Are we making a two-cycle oil? So when you get ready to formulate this oil, you have to know what your end product is going to be, and then you can build your product to meet that end application. Now, the other part about that is, once we determine, in this case today, we're going to talk about making a standard motor oil, gasoline motor oil for a passenger car, to recognize, well, how will we know and who will certify that we've actually made what we set out to make? Well, excuse me, the American Petroleum Institute, the API, gets together with a committee, a steering group, which is made up of the manufacturers who make the engines that we're going to lubricate with the oil, and members from the major oil producers such as ExxonMobil, Chevron, Texaco, Shell, and it would have General Motors, General Motors, Toyota, Nissan, Ford, Chrysler, Mercedes. These people would participate in this organization to determine what the criteria or specifications would be for this oil to meet their needs. See, that doesn't work that the oil company makes an oil and says, here, you can use this. You have to meet the needs of the manufacturers of the equipment. So they're the ones that are going to set the standards. And by the way, sometimes as we move further to wanting greater performance out of oil, we don't even have a test to meet the requirements. So one of the problems is you have to develop a new test. And by the way, that test will be certified by the ASTM in order to say that, yes, that's a good repeatable test and is not influenced by human action, that it can be run independent by any person and get the same kind of results. So it gets pretty complicated to determine exactly where you're headed and to set out with this. So we've got to know that to start, because otherwise we're just, it's an old saying, if you don't know where you're going, you probably won't get there. Okay, so we've got to know where we're going. Today, we're talking about making a gasoline engine motor oil that would meet the current API SP spec. Okay, and we've talked about those before. So again, in that previous information, I don't want to rehash what SP means versus SL or SN. That's all in those previous videos. So here we go. To make a finished product, we've talked about in a previous video things called base stocks. This is the actual liquid base of the product. Now, that can be petroleum. It could be a blend of petroleum and synthetic. Now, under synthetic, it could be what we call a hydrocracked synthetic. That, again, has been talked about in a previous video. Or it could be a polyalpha olefin, a PAO, or an ester. Or today, a great new area they're venturing into is what they call GTL, which is gas to liquid, which has been really, really perfected by Shell Oil Company over in Kuwait, or might be Qatar. Don't quote me on that. It's one of those two countries on the Gulf over there. I mean, on the Persian Gulf. So, okay, we got to pick our base stock. Once the base stock is picked, we know where we're going. Then after that, as I brought out in detail to you in a previous video, you got to put additives in this oil. Now, why do you put additives? Additives will tailor the oil to the finished product, what you want it to be. You'll have a little bit different additives for a diesel oil versus a pure, just simple gasoline engine oil. And then you'll also have different additives if you're going to make a marine grade oil versus a motorcycle oil. Okay? So, again, we all know where we're going there, and that's how much or how little or which additives that we're going to use for these particular applications. Now, as you recall, motor oil or any lubricant, one of its major functions is to prevent friction and wear. So, okay, we're going to use additives to enhance and ensure that we can prevent wear. Now, what do I mean by that? Regularly, if the oil separates the two moving metallic components, there will be no wear. They have to come close enough together to have a rubbing effect before there's going to be a wear and friction. And in a fluid that can maintain that separation, we wouldn't have to worry about it. Unfortunately, in an operating internal combustion engine, there are several locations where full fluid film is not possible. This would be in such places as rocker arms, push rods, camshafts, and ring cylinder interface. So we're going to be forced to use some type of additive to ensure that we do not have wear in those situations. And, excuse me, without getting into great detail, most of our anti-wear additives in gasoline motor oil are some type of derivative of a chemical compound that includes zinc, phosphorus, calcium, and maybe sulfur. Okay, these are anti-wear additives that will be put into the oil so that when the film of oil cannot maintain the separation of the moving parts, they'll rub zinc to zinc or calcium phosphorus to calcium phosphorus, whatever, without reaching the actual metallic surface. We'd rather wear out some zinc than we would wear out the metal surface. Okay, so those anti-wear additives are critical for reduction of wear. And for goodness sakes, we want this oil to be able to protect this engine and for it to go 500,000 miles. We do not want to have such poor anti-wear that we're lucky it's going to go 50,000 miles before it's worn out. Okay. Next, the number one enemy that attacks our engine oil is oxygen. We need oxygen to live, but I can tell you one thing, most of the stuff in and around us, oxygen simply oxidizes it, which means that it deteriorates it. Everywhere you see rust, when you see any type of breakdown, it's usually got to do with oxygen. Oxygen is a very strong chemical element with a -2 polarity, meaning that it is ready to jump in and interfere with any compounds where it is. Okay? So we're going to put in an additive that's going to help us prevent our oil becoming oxidized. And by the way, if we're using a high quality synthetic can end up being inert. In other words, it can mean it has no open sites to react with that -2 oxygen. However, petroleum doesn't have a chance in that area. So we have to add significant antioxidant to any petroleum formula to prevent it from becoming, and if it's oxidized, it makes sludge and varnish. That's the result of oxygen, okay? Pour point depressants. If you have natural petroleum oil, it's got wax in it. Wax crystallizes at very low temperatures. If it crystallizes, you end up with cotton candy instead of oil. So you have to put something in, a chemical that will inhibit the crystallization of the wax. Therefore, the material will stay liquid and be able to pour at very cold temperatures. Now, when you move over to hydrocracked, even hydrocracked oil or pure base in the synthetics, they don't have any wax in them. So they don't need to pour depressants because they're not going to formulate any wax. So they're going to pour naturally at very cold temperatures. We got to make sure we don't allow the engine oil to get foamed up. That would be full of air and entrained bubbles. If you do that, imagine I got liquid, I'm trying to hold two things apart, but half of it's air. It's just not going to work. So foaming just defeats liquid lubrication. So I have to have something that I add to the oil to enhance the bubbles leaving the oil quickly, not staying in it. Okay, so we use certain types of chemical additives, usually either silicone or polymers, which enhance the ability for the bubbles to escape and leave the oil. So that's what we're trying to do, get the air that's entrained out. Those are foam inhibitors. Now, we've talked before about viscosity improvers. We're not going to go into that in detail. Viscosity improvers, we put them in there so we can have multi-grade oil. If I want a multi-grade oil, just understand this. The wider the band, if I had a 5W50, it's going to take a lot of viscosity improvers to make a 5W50 oil, whereas a 10W30 is not going to take nearly as much, okay? So we'll leave it at that for future discussion. Total base number. What does total base number mean in mixing this oil up? Well, if your oil ever reaches an acidic number in pH, okay, and I'm just going to assume that you know what that means. If I have an acidic pH, it'll eat the faces off of the bearings in the engine. So I cannot allow oil to ever become acidic. Total base number is a number used to tell me how much acid this oil could neutralize before it loses that ability, okay? So the TBN is a measurement that we have to look at to ensure that our oil is in a condition to continue and will not become acidic, okay? Dispersants and detergents, we talked about these in detail before, but you got to put them in there because I want the detergent to scrub the walls. I want the dispersants to maintain the scrubbed off particles in solution long enough to coagulate, get to a filter, and be taken out of the oil. So dispersants and detergents are necessary for us to have an oil that will continue to clean the engine as well as lubricate. Okay. Rust and corrosion inhibitors. These are more important in marine grade oils, but even in automotive oils, we find that we need these because we do make motor oil for classic cars and vehicles that don't operate all the time. And the other thing is, if I have a short trip type car that doesn't ever get up to a lot of temperature, it's got quite a bit of moisture left inside of it, and I need to make sure it's not rusting away as we're driving our short trips all the time and never bringing it up to full temperature in order to remove the moisture. So now you can see that there's both a science and an art to making a finished product in motor oil. I've gone over some things here so that you know how it's formulated together. But what we'll do in our next version, our next video, is we'll talk about this very thing, but then we're going to go into, well, why would you use a synthetic in a particular over a petroleum, and what those advantages be disadvantages. And in these additives, are there some that are better than others to do the job, and why would you pick one over the other? So that's to get into more of the preferences for how you would formulate one of these oils. Now, that comes back to one simple thing, and I'll close with this. Oil, the old saying is, Earl is not Earl, okay? These guys all have their own way of making these products. That's why You have people who will tell you that they've gotten better performance out of a certain brand of oil. Well, the truth is, these guys, when it gets to making this finished product, they will vary in both the quality and the amount of these additives that they put into this oil, because these additives are the expensive part, especially of a petroleum oil. The additives will cost about 80% of the cost of the quart of petroleum oil. That'll back off to maybe around 50% for petroleum. But these additives are not cheap. So I'll end it with that and encourage you to look for the next video coming. And to remember, if you're looking to purchase any kind of synthetics and you want some help with getting the best product you can, then I'm in that business. I am in the AMSOIL business, and I would appreciate your business. So you can get in touch with me through the website, plenty of information that you see on this. You can call me at 800-370-2986. So I'll see you next time.